Hello, in this video we're going to keep talking about bonds, and we're going to solve a problem that could explain the complete life of a bond. So let's consider a bond that has a face value of $1,000. So the bond has a face value of $1,000. The bond rate is 5%, and the coupon is therefore $50. The time to maturity, the life of the bond is going to be, the complete life of the bond is going to be 20 years. And the first, you're going to have two owners. The first owner, the first bond holder, will have a yield of 6%, and he's going to hold it for 8 years. So even though the life is 20, he's going to buy it initially at the face value, and he's going to hold it for 8 years. So the question for this part of the problem is then what was the selling price for him if he's making 6%? Well, the question that we have is the present value, which is $1,000. He acquired it at the face value, should be equal to the bond coupons, which is $50 times P given A at 6%. The yield he got was 6%, and he received eight of these coupons, plus the selling price, which we don't know yet, times P given F for 6% and 8 periods. So solving for the selling price, we have the selling price is 1,000 minus 50 times P given A, the value is 6.2098 divided by P given F, 6% and 8, the value is 0. 0.62741. So the selling price is $1,098.98, and that's how much he sell it for. Now we need to question ourselves what happened with the second owner if the second owner hold it to maturity. Okay, for the second owner, we have that the purchase price was $1,098.98, and the selling price, if he holds it to maturity, is predefined as the face value, so he's going to sell it for $1,000. The coupons are also defined to be $50, and since life was 12, then he's going to hold it for 12 periods. So the question is, what is the yield for the second owner? So we can write the expression $1,098.98 should be equal to $50 times P given A with a yield that we don't know, and we have 12 periods of that, plus 1,000 times P given F for that same yield, discounting over 12 periods. Now this expression is not easily solvable in one attempt. You cannot find the solution immediately just algebraically. However, using the computer we can find that the yield is 3.959. So if we compare that to the original design percent, if we compare that to the original design, originally was designed to pay 5%. Of course, the second owner is not going to make 5% because the first owner made more than 5%. The first owner made 6%, and therefore the second owner is going to make less than 5%. It is not 4% exactly because also the amount of time is different for both. The amount of time that both kept it. So that's why we have these differences between the 5%, the 6%, and these 3.959%. For purposes of the test, you might have to find the yield in a different way, and one way to do it is by interpolation. So the way we do this is we compute the present worth for both, say for instance, 0% discount and 5% discount, trying to see what happens. And of course, for the first case, since we are not discounting anything at all, we're not taking into consideration any time value of money, the present worth of this investment would be $501.02. That is, he or she has to invest $198.98, and it's going to receive $50 times 12 plus $1,000 without any consideration of when they receive it, and that amount is $501.02. Alternatively, if we discount it at 5%, then that implies that the value would be negative $98.98 because the instrument was designed to be worth $1,000 if it's discounted at 5%. And that now we have 2 points, a point at 0% on the present value and another value at 5% present value. And now we're interested in finding the interest at which the present value of this expression is 0. So we make the assumption of a straight line between these 2 points, and the intercept at 0, or when the present value is equal to 0, would happen by interpolation at 4.175. Now, the reason why we don't have the same answer is because the present worth is not a straight linear function. However, this is close enough, approximate, good enough for your test. In order to explain what's going on with the interpolation, here we have a graph that represents the present worth in the vertical axis and the rate of discount for the second owner in the horizontal axis. And we see that if it's discounted at 5%, the present worth for the investor is 98.98 negative. If there was no interest rate, then the present worth for the investor would be 501.02. And with the interpretation that we do, assuming a straight line, we get a slightly larger value than when we actually compute the numbers, because the interpolation assumes a straight line, whereas the actual value for the present worth is not a straight line. In such a way, the gap that you see between the two lines where they cross the horizontal axis is the difference between them, the 3.95 and the 4.15%.